Hi everyone. Yeah, my name is Minko Gechev. I work on Angular, one of the leads on the project there at Google. And today I would like to share with you more about what has been going on in the Angular community lately. So there has been a lot of movement, I guess, a lot of momentum in the Angular community. And Angular is one of the oldest frameworks out there. The first release of AngularJS was, I guess, around 2010 or so, which so this is about 14 years ago. In JavaScript years, this is at least, I don't know, 10x or so. I'm actually curious, how many of you here have been using Angular? Great, actually, that's exactly the kind of audience I was hoping to get here. And I would really appreciate the feedback about these new features that we could be working on, and we'd love to show you more about it, tell you more about it. So what does this think about the Angular Renaissance? You know, we have talented team, we have a really great pianist, for example, but we are not really getting into arts and crafts. We have been just shipping a lot lately. So we shipped something called deferrable views that I'm going to show you a live demo in a little bit. We shipped new control flow. We shipped Material 3 version, so we work with the Material 3 to define what actually this means for the web. And new signals API. So signals, they have been a hot topic in the JavaScript community lately. And way more, across the Angular CLI, across Angular DevTools, Material, and so on and so forth. So that's actually our goal. We are a framework that just aims to make you confident in delivering web applications. And we have been focusing specifically on performance, developer experience, and stability and reliability has been really high on our list. We kind of don't want to make you feel adventurous, whether your project is going to work or not tomorrow. We have been making sure that also we don't repeat the same mistake that happened with AngularJS and Angular. And in fact, every single commit that we ship from GitHub, it goes inside of Google. We're syncing it inside of the Google model repo, and we are running all the affected tests. So there are hundreds of thousands of tests, and only one of our projects there, Google Cloud Console, is about 17 million lines of code. So if there is a breaking change, we would know about it. All right, so first I'm going to talk a little bit about signals. With Angular signals, there was a lot of community attention. We got about 1,000 comments in our RFCs on how we're going to include signals for fine-grained reactivity and how are we going to evolve Angular APIs to use signals a little bit more natively. But actually, it turned out that there was more excitement than we originally anticipated. So at Google, we have two frameworks that are two major web frameworks. We have Angular and another framework called Wiz. So Angular is often used for very highly interactive applications. For example, BART is built with Angular. We also have Google Analytics, Google Cloud Console. They're all Angular applications. You often have a lot of forms there, very highly interactive apps. And often they're enterprise focused. And on the other side of the spectrum there, we have Wiz. Wiz was a framework that was originally built for Google+. And it is the piece of infrastructure that survived, and it has been powering all the billion user products of Google, such as Google Search, YouTube, Google Photos, Google Drive, all that Google stuff. And so we noticed that more people were using Wiz. They wanted more of the developer experience of Angular, and more of the people using Angular, they wanted the performance of Wiz. One of the things that specifically Wiz was excited about was signals. And they introduced signals directly in YouTube. So 100% of the YouTube's mobile web traffic right now is using Angular signals. That's pretty much what the web apps that YouTube maintains. They have a web app for living room. This is all the smart TVs are running JavaScript and the web app there. There is the desktop and the creator and the mobile web. At the moment, Angular is right here, but they were pretty quick in rewriting this whole user interface. So I'm anticipating things to. Oh, actually, Angular is right here too on the TVs as well. Specifically, what they liked about it is the universal browser support. Signal library. We're actually going to look at the signal implementation in a little bit. it doesn't have like two unique constraints. It uses pretty standard JavaScript API, so it doesn't have to be bleeding edge ES 2023 or something like that. The signals are also like pretty small library overall, so meets the bundle size constraints, and it performed really well on synthetic benchmarks. Like if you know the JS framework benchmarks, so we're going to look into that in a little bit as well. They're still like YouTube is still using signals actively. So a couple of questions that they're going to answer is: are the performance gains actually going to scale over time when their code base reaches a couple of hundreds of thousands or million lines of code? And also, can we model existing patterns with signals and whether they actually incentivize cleaner code? That's something that we're going to learn and we're going to share in the next year or so. But some of the benefits that they're seeing right now, for example, in living room, that's on your smart TV, they saw 35% better input latency on low-end devices. For their video player here, the scrubbing is 60 frames per second. Previously it wasn't. You can see the glitchy one on the left and the signals version on the right. And same with swiping on YouTube mobile web with YouTube Shorts. This is all using signals nowadays. So there were quite some benefits with signals, and we're moving like full on with them actually. And I just wanted to tell you how exactly Angular is using signals, because sometimes when I talk to like an audience that is not Angular developers, and I talk about signals and fine-grained reactivities, I often get a question, yeah, but like virtual DOM is faster, right? So it's actually not faster. We're going to dig a little bit more into that, but specifically here I'm going to focus on signals and why fine-grained reactivity actually could make a big difference. Virtual DOM has great marketing name, for sure. So here I have proposed a very simple implementation of signals. This one is, I just copied it from Ryan, who is working on Solid.js. We worked together in order to make sure that we introduce signals in the right way in Angular, since he has been having a lot of experience in this space. Here we just have a function called signal that accepts like a value, and it creates a closure and returns these functions, read and write. So if we look at read, pretty much all it does is it gets like a current observer, let's say, and adds it to a set of subscriptions, and after that returns the value. The interesting thing here is write. So what write does is just goes over all the subscriptions, and for each one just calls it. That's pretty much all of it. Now there are the implementations of the current observer and function called effect. They're not that essential for like the purposes of what we're going to show next. Pretty much what matters is that when you create a new signal, here the signal is called with, and you read the signal inside of an effect function, when you update the signal value, this effect callback is going to be invoked. That's pretty much the whole thing. So this can power the whole change detection mechanism of your application. The change detection is how like view model updates or changes in your data are reflected in the view, and why they're like very fast. Like Signal has proven that, Solid has proven that really well. So in Angular, that's a typical Angular component where we have a template. Inside of this template, we just have one binding. We're reading a signal here. Also, just to point out, this is not the Angular signals implementation. I just picked this one because it could fit on one slide. Inside of the class here, we just create a new timer property. We assign it to be a signal of 0. And inside of the constructor, we have set interval with timer that we increment every second. So Angular takes the template and compiles this to isomorphic JavaScript. So it's going to turn it into something like that. This is still made up code. It is still the code. I wanted to make it a little bit like simplified so that it can fit on this slide here. You can notice that this class where you're keeping your logic is exactly the same, and the template is compiled here to an effect call, where in the callback we're passing, we're pretty much verifying whether we are updating the view. Usually there is one more block here for creation, and we are reading the timer. We're just setting a text node. So what this means is that every second, just the effect function is going to be called and is going to update the view. So we go directly to this exact text node that we're interested in, and we update the view. We don't have to perform like any reconciliation, compare like any kind of trees at all. And this could be on any kind of granularity. Here the template is pretty simple, and we wrap the entire template in an effect. But eventually, we can make it. We can like wrap every individual binding in an effect if we decide to. And it's going to be pretty transparent actually for developers because it's just a generated code. That's the approach of Solid. In Angular, we decided to go not as fine-grained for now, but we're still getting similar benefits. All right, that was about what powers the change detection. Actually, in practice, it's also going to be slightly different. We're not going to directly go to the DOM and update it. We're going to just schedule an update. And we're going to look only in this part of the DOM rather than looking at the entire DOM tree. Any questions about signals or how they trigger, how they power reactivity? Yeah?
I don't think there's another product called RxJS.
Yeah.
I used to use. And the difficulty with it was subscription and unsubscription. It seems like you dodge that completely. How do you unsubscribe and don't unsubscribe? How do you ever free up this?
Yeah, you can automatically, it is handled like automatically. So in fact, like subscriptions are very tightly coupled with the hierarchical like dependency injection of Angular. So whenever a certain component gets destroyed, we clean up all the associated subscriptions with this automatically. You don't have to do anything. But this has some constraints on where you can use effects, let's say. You can use them only in particular places.
Okay.
Yeah. And I have a slide about RxJS also in the interop there. Yeah?
So I don't quite understand this code. Where's this update coming from?
Well, this update, yeah, sorry about that. It's just a flag. It's well, update is supposed to come from here, so it knows in what like state we're running this template function. It is because usually in Angular, the code that we generate has two different sections. One is for when you're updating the view, and one is for creation of the view. And I just submitted the creation. The creation would be something like I don't know, create text nodes and attach it to a DOM element. Yeah.
Oh, so it's the mental model that a developer is supposed to have is that whenever you push the state, it will lead to a DOM ping.
Not necessarily. It's going to schedule change detection. It's going to like schedule things, let's say.
Okay.
Yeah. Yeah.
Now, I've been looking at your signals code to like integrate it in some of my own stuff. Is the signal stuff mostly drop-in, or is there like magical interaction at a distance with other Angular stuff, like the compiler or the CLI or anything?
There is, well, the compiler will generate slightly different output if you're using signal bindings. So it is, I guess, in this way, magical.
Okay. But like, if one wanted to use a similar signal architecture in a different framework,
oh yeah,
like one could adopt just the Angular signal part, just like copy that module out and.
Yeah, you can do that. Yeah, that's what YouTube does. And yeah, something I don't mention actually. Over time, Angular and Wiz are merging. So we're going to turn into potentially one framework. But as you know, like merging frameworks is I haven't heard about like many frameworks being merged. So it's going to take a lot of time. Over time, we're just getting inspiration from one another. This was one of the inspirations specifically around signals. So we merged in our reactivity model. After that, we're going to merge into kind of this hierarchical, like ownership context or dependency injection. And we're merging on one more thing that I'm going to talk about. Yeah? Two more questions.
If you ballpark this roughly against writing DOM code directly, what's the approximate overhead of signals over if you just wrote all the code out straight using the DOM?
Yeah, there is in JS framework benchmarks you can see that really well. I would suggest comparing probably with Solid.js because it's the closest to like the finest grained reactivity possible that they have there with signals. It is pretty close. Still, like the actual like DOM manipulations are faster, but also you're getting some developer experience benefits by not doing it from scratch. Yeah.
Can you do operations with signals like flat map or concatenation?
No, if you like to, you can convert the signal to an observable. and do all that stuff. Yeah, that's another thing about, I didn't include RxJS because I assume there are not going to be that many Angular developers here. So there is an interop level. Okay, I'll just continue and tell you more about model inputs here, and from there we can dig into performance and server-side rendering. So this is kind of the back in the day when I started. I guess I was back in university 2010, 2011. This is something that I liked a lot when I saw in Angular, just this two-way data binding. For example, when I update the checkbox right here, like the checkbox has an internal state, whether it is checked or unchecked. And this profile that uses the checkbox, it is a parent component. It has this isAdmin property that is passing through the checkbox. And ideally, what I would like to have with two-way data binding is when I change the state of the checkbox, I would like to also update isAdmin. So if the checkbox is unchecked, I want this to be false. Otherwise, I want this to be true. And with signals, we made it significantly simpler. So that's all you need to do. In your who checkbox right here, you just have a model, which is false by default, let's say. When you update it, you just toggle the value. This is the actual Angular Signals API. You have an update method. And this allows you to have this two-way data binding. That's pretty much all you need to do. So this is one of the new Signal APIs that we introduced. Everything that we had before continues to work. And if you're not using it, we're just going to eventually tree shake it. So it's not going to be part of your production bundles. But that's one of the benefits that we have been seeing with Signals. All right, and what I mentioned about RxJS and Signals, the cool thing, like RxJS and Signals, they solve different goals. I would say RxJS is a little bit more general purpose. You can use it for things like just managing streams of data. And it provides a very expressive API. I personally don't use it all the time, because there are so many operators that I can't really remember them all. And I'm struggling a little bit with the semantics, but a lot of people are very successful with it. So we wanted to make sure that these people continue to be successful with it by also making it optional, so you don't have to necessarily use it if you're using Angular. And we extracted all this interop between Signals and RxJS in the Angular core RxJS interop package. So it enables you to build more RxJS-friendly experiences if you want to, but also if you don't want to, you can just use Signals. All right. And yeah, since Angular has a compiler, we can also provide some smart diagnostics. So let's say here in this if statement, the signal value, signal is a function, so it's always going to be truthy. So we can verify whether you're using signals the right way and provide you some diagnostics. All right. I'll also briefly touch on control flow, and after that I have a performance section, and we can chat more about the whole thing. So while we were designing Signals, we wanted to make sure that they provide an ergonomic API. And we gathered a random group of developers who were using Angular, some people who were using React, Vue, Svelte, and so on and so forth. And we gave them an assignment to build a very simple to application with Signals. And we watched them build it. And like we saw a lot of people struggling with just the control flow, like iterating over the items. And to be honest, like I've been struggling with ng4 too. Like I don't remember the microsyntax all the time. So we decided to implement a new control flow with these user studies. And we found a syntactical inspiration. It was kind of inspired by Svelte at the time. And we published an RFC. In the RFC, we got even more comments than Signals because everyone likes syntax, and it's a fun topic to discuss. And we got one of the proposals in the RFC was an alternative syntax to what we originally thought about. And everyone seemed to love it. And we ran a bunch of surveys. So we ran a survey with, we collected about 12,000 responses or so, comparing both syntactical approaches. And the community proposed one actually won. So we moved forward and we implemented it. So that's how you use control flow in Angular now. It looks very similar to JavaScript, but still it is in your string templates. And we want you to have string templates because we can they're statically analyzable, and we can optimize them. We can actually generate pretty efficient source code this way. It is inspired by JavaScript. It has good type narrowing because we have type checking, pretty good type checking templates. And also it turns out it's like way faster than the previous one. It's about 90% faster for certain benchmarks. And here I have omitted the other frameworks because they don't want to start like a war. But you can imagine which these frameworks are. So it turned out to be pretty fast. We were mostly working on the ergonomics, but we also updated the diffing algorithm. We wanted to make sure that, I mean, actually, if you look at the previous version of Angular with the original control flow right here and the current one, actually we were just not doing great with swapping roles. That was the only thing. And we don't consider that like everyone is just swapping roles all the time. That's why we didn't optimize for it. Yeah?
How did you read this graph?
Sorry?
How did you read this graph?
Oh yeah. I would look at the bottom row. It just contains the weighted geometric mean. So you just the smaller the better. Yeah, and the greener the better too. Yeah. Yeah, Build.com, they tried it in production, even though this is still in our developer preview. They saw 1 second reduction of their largest contentful paint, which we didn't anticipate, honestly, but worked out pretty well for them. And because this was, well, we still support old control flow, but still we would like more people to use the new control flow. We have we call it schematic. It is like a code transformation that would update your whole application to the new control flow. And we run it on a lot of code at Google, so we're pretty confident it works fine. All right, so that was about developer experience. I have some stuff about performance now. So we introduced a feature kind of long time ago about declarative lazy loading. And if you're using React, I guess this is going to be similar to React Lazy in a way, with a few features on top. So it allows you to just wrap part of your component tree. Just you annotate it in a specific way that I'm going to show in a little bit. And all that stuff is going to be extracted together with all of its transitive dependencies into a separate bundle. And also, you can specify when you want the stuff to be loaded in a declarative way as well. So let's say we can specify that we would like it to load when like a placeholder enters the viewport. So inside, it uses something called intersection observers and manages all this complexity for us. And yeah, just loads lazy. I just want to show a very quick demo. It's like do it up for the next demo that I'm going to show. Yeah. All right, I have a very simple development server and a super simple app. It just does blank page, and I have a chat box here. But imagine this is an e-commerce app, and you have a chat box on the left or on the right or wherever. And you know that like most of the time, users will not engage with this chat box. You may have maybe 1% of the users that engage with this chat box, and if you don't lazy and you load it, you're going to be paying the cost of having this JavaScript part of the main bundle all the time, just like we have it right here. This is the main bundle of the application. And you load it eagerly, and it's going to be really fast. I mean, we're going to open it, we're going to start typing immediately, but if the majority of your users are not using the chat box, it just doesn't make sense. So something that I'll rather do is just lazy load it. With the new deferrable views, you just use this instead. And you specify that you would like this to start loading when the placeholder enters the viewport. That's pretty much the whole thing. Now, when we go to the main bundle, the chat box is not here anymore. We have a deferred template. So here the Angular compiler is going to generate some code for us that is going to lazy load this whole thing. And it's also going to ask some instructions for interaction with intersection observers. So when we expand the chat box, we're going to download the actual code and we're going to render it. And yeah, this was on these 2 lines of code. So that was one of the new APIs that we introduced. Worked out pretty well for build.com again. They have they saw 50% reduction, but we wanted to expand it a little bit further. And because currently when you render it in a hybrid rendered application, so on the server we're just going to render the placeholder, the thing that you saw as like loading ... So we wanted to think about the semantics on the server. How would it behave in there? And I'm going to get to that point. Before that, we wanted to incentivize more people to use also server-side rendering. And in version 17, we saw about about 30% more people. So compared to version 16, there was like 30% growth, and people are seeing improvements with server-side rendering. And actually, this growth mostly came up from us updating our build pipeline for SSR, relying more on EU's built in this case and on Vite. Now, after listening to Jared's presentation, maybe we should rely on Bun and Bun, I guess. So I guess the way it works is we run ng-build, which is the build command for Angular applications. You have the Angular compiler here that generates TypeScript out of your templates. After that, TypeScript performs type checking and eventually downlevels it. We have a build optimizer that further traverses your code and makes sure that certain constructs without side effects are marked as such so that they can be tree-shaken away. And after that, we produce 2 different bundles, one for the server and one for the client. But up to this point, like everything is happening just for one environment. So we just produce 2 different bundles at the end. And yeah, so with this, we improved build speeds with 87%. Actually, Vanguard reported 3 times faster builds. And the way it works traditionally, server-side rendering, you have your browser and you have a server. You send a request to the server and it returns response. And with this response, it returns the rendered page, just the HTML that is rendered in there. And the browser is going to download all the reference scripts and it's going to hydrate your application at once. Which, if you have a lot of JavaScript, this can increase your blocking time significantly. And it can, and from there, it can reduce your core web vital metrics. Something that we have been, yeah, there is debugging for this. Something that we have been exploring with Wiz, though, is how we can make it a little bit more gradual, rather than having the whole hydration happen at once. So about when Google Plus was a thing, I guess, that was, I don't know, 10 years ago, Wiz introduced this concept, which now quick made popular, called resumability. And it introduces a different approach. So when you send a request to the server, you get the rendered page, but there is no JavaScript associated with it. There is just like a very thin event delegation layer that handles event. And when the user engages with the page, this event delegation layer figures out what JavaScript it needs to load so that it can download it and make this specific page of your application interactive. So you have significantly faster interaction to next paint. This is one of the core web vital metrics. And the way it works is the library is called JSAction. The way it works is that and this library is, I don't know, like 2 kilobytes, maybe a little smaller. The way it works is it handles the user event. Just first, it adds an event handler at the body. When the user clicks on this button, just the event bubbles up to the body, where JSAction handles the event, and looks up on an identifier that is on the button, which is the controller that is responsible for handling this event. And from there, we can download the code associated with this controller and replay the event so that we can just, I don't know, execute the user interaction. So this is actually landing in Angular right now. There is an open pull request. And I wanted to show you in practice how it works with very fine-grained code following. All right, this application here looks like a mock, but it's actually a real running application. We can look at that. So you can see that. So there are a couple where you see add defer. These are just deferred blocks similar to the deferred blocks that we had previously. And by default, they're rendered on the server, but we don't deliver the JavaScript associated with them to the client, so that you don't have to get into this situation where you need to hydrate a large component tree with a lot of JavaScript and slow everything down. However, on interaction, let's say we want to add to the cart, and I can open the network tab as well. Let's say I want to add this to the cart, and this is also intentionally slowed down, so it can actually show that something is happening. When I added something to the cart, it downloaded 2 chunks of JavaScript. One of them was for this product right here, and the other one was for the details. And also, I'll refresh. It also updated the items from 0 to 1. So here, clicking on it, started downloading the code, downloaded the parent, downloaded the child, and after that updated the shopping cart. Again, this is intentionally slowed down with a couple of seconds so that we can see what's actually happening. And this part of the page is still not hydrated, and still we haven't downloaded the JavaScript associated with it. So when we click on it, we're still going to trigger hydration. We're going to catch the event on the high level. We're going to see which is the JavaScript associated with it. We're going to download it and hydrate the specific part of the component tree. And we're going to do the same with this one here. Yeah, if you look at the code, and in order to achieve this, you don't have to rewrite your application. You just need to wrap. Sorry about the location thing on here. You just need to wrap your page inside of this deferred block, and this happens automatically with fine-grained integration. Now, a couple of good questions are: do we really need to download, let's say, the parent component when I click on details? And here, we potentially need to do it, because let's say if the product passes some property to the details component, we may want to know about these properties. There might be a future in which Angular serializes the dependency graph, your signal dependency graph, so that you can have resumable signals. That's something that we'll be exploring next. In this case, we will know that if we add a new product to the cart, and we're reading this associated signal in the shopping cart right here, we can just hydrate the shopping cart without hydrating any part of the component tree. All right. That's the demo about partial hydration that I wanted to show. Do you have any questions about hydration or server-side rendering? Yeah.
So that on interaction, that only happens on click, so there would be some delay for the user maybe if there's high latency or something. Can you do that on hover or other as well? Okay.
Yeah, it could be on anything. And something that Wiz has been doing for a while is they would use a heuristic to prefetch the JavaScript that is likely to be used.
Okay.
Yeah. Cool.
Very cool.
And there is an additional optimization, because you could potentially have thousands of bundles if you have a big application.
Yeah.
So at Google, we are running something like a very simple JavaScript bundler on the edge. So when you send a request, it bundles everything on the edge on demand and returns it. And you can imagine that it comes with trade-off, because caching may not work all the time this way. Yeah.
How fragile is this stuff? If the app author adds some more listeners and prevents bubbling of events or whatever, is it easy to break this?
It's still in development, so we're about to see. In Wiz, it has been working pretty well for a lot of applications. So I anticipate it's going to be fine. But yeah?
I'm guessing this works best with static pages. If you have an animation on the page, how are you gonna work with that use case for a certain update?
Yeah, it depends on the animation also. It could be just CSS transitions, could be just like CSS animation, for which case you don't need JavaScript and it's going to work just fine. Otherwise, you can just eagerly load only this part of the componentry and hydrate it and not download the rest. Yeah. Yeah.
Have you explored streaming as well, or only when you?
Yeah. We have explored streaming as well, and we figured out that this actually would make a bigger difference. So that's why we prioritize this project sooner. We have a prototype of streaming as well.
Okay.
Yeah. Yeah.
If the embedded one was like a defer on viewport, would that then the parent like defer on interaction?
Yeah. Currently in this prototype, this actually we're going to ship this probably in June. Currently it works only with interaction for server-side rendering. But let's say, so if you said if the parent had on viewport and the child had some interaction, or
like if the deepest one had viewport, but then like a parent one had interaction, or like total.
Yeah, in this case everything would download, just because we download the parents in case they have any dependency injection requires or anything. And we are considering changing this. So some people call it like a donut hydration, just because you have let's say the top level component is hydrated, intermediate components are not hydrated, and a child component is hydrated. It looks like a donut a little bit. It's it would require slightly different primitives to add to the framework, in which we guarantee that the parent doesn't provide any states to the child, let's say. Yeah. Yeah.
Is there a way to, if like your network's idle, start downloading things and have them kind of deferred for odd use?
Yeah. You can do that also really well with service workers and cache them ahead of time. Okay. All right. Yeah. So we wanted to spend some time talking about the community as well, because we have been having some folks doing some great stuff. Like Brandon, he built some meta framework, and he introduced a new authoring format, because I've been hearing the sentiment in the JavaScript community that people don't like classes. So if you don't like classes, you can also use this thing, which is very similar, I guess, to Svelte and Vue. Brandon's meta framework analog also has whatever a meta framework you'd expect to use to have like API routes. It has like a file with your file structure. You can describe your routing tree and much more. So analog just reached 1.0, and it's a pretty cool product. And some people started implementing integration for Angular with the town stack as well, which seems to be popular in the React community. Actually, this is a little bit out of date. We currently have, there is one more community member who implemented support for town stack forms. So now we have town stack query, forms, and store. Oh yeah, and well, since one thing has been kind of constant for Angular pretty much since 2010, it has been this red shield. And it is just so 2000 and, I don't know, whenever HTML5 got introduced. Just a long time ago. I know at a certain point we did some updates, we removed the border, and that was pretty much it, which confused even more people between Angular and AngularJS. So we wanted to refresh the log a little bit to reflect all the features we have been building and the momentum we have been having. And we added the gradient. Thank you. Yeah, and a new documentation website. It is currently intentionally not indexed by Google search. We're going to make it the default in version 18. And also, yeah, we have, we release 2 major versions a year. Just that's what we do. It's just predictable release schedule. And sometimes the breaking changes are we just update the TypeScript compiler, let's say. And the TypeScript compiler, they have, let's say, fixed some bugs and made the type system a little bit more strict, which is kind of like a breaking change. So we need to release a new version of Angular when we update the TypeScript compiler. Even though it's mostly null for a lot of people, it still makes sense if we follow semantic versioning. Yeah, and what's coming up next? Yeah, a lot of things. We're going to ship a lot of more things coming up in the next couple of releases. Yeah, and they're all going to be focused around performance, developer experience, and we're really focused on stability and reliability. It's priority for us as well because we maintain Angular for the whole Google, and if we break something, we have to fix it. And imagine like fixing bugs in someone else's code. It's not trivial. Yeah, that's all I had. If you have questions, I'll.